Hi everyone, my name is Riley Archuleta, and about I'll be presenting to you about block design. So here's my table of contents. Slide 3 will be discussing the RCBD and CRD definitions and differences with some visuals. Slide 4 would be steps of designing RCBD, including the randomization, but I won't go all the way into it. And then for slide 5, we have the photos and explanation of field design practice with photos from from the experiment that we did in class. Slide 6, we're going to compare the ANOVA tables to CRD and RCBD, and then demonstrate how to analyze RCBD data using MS Excel. And then for our final slide, I'll be doing a vocal summary. So RCBD and CRD definition and differences. So our CRD is completely randomized design. So entails the experimental units are assigned to treatments completely at random. Each experimental unit has an equal chance of receiving any of the treatments. This design is suitable when the experimental units are relatively homogeneous. So CRD is pretty much you could have all your replications and treatments. So say you have 16 replications. Each one of those treatments could, or each one of those replications could have any of the treatments. So that is CRD. But then when we get into randomized complete block design, which is RCBD, um, the experimental unit groups are called blocks. So instead of having all of your replications just in kind of next to each other, you will be using blocks, and I'll have a visual for you to explain a little bit better. Within each block, the treatments then are randomly assigned to experimental units. So if you have treatments A, B, C, D, E, each block will get A, B, C, D, E. And like I said, each appears exactly once in each one of the blocks. This design is used to reduce the error by accounting for the variability between the blocks. So usually this will be used for experiments that have slopes. Error of that slope is canceled out. So right here is pretty much a visual of RCBD, which is the randomized um, con controlled block design. So we have block one, block two, block three, block four, and then you can see that I have the slope at the bottom. And it also depends how you set up your block design of the way that your slope is going. So with block one, as you can see, we have B, E, C, D, A. So A, B, C, D, E, there's only one in each one of those blocks. And then you have block two, block three, block four, and it's saying the same, it's doing the exact same thing, but then of course, each one of those treatments is randomized. In the next photo, I'll be showing you, but a little bit more how it was set up, but you could see when we have the 10 feet, which is the distance that we made between block one and block two. And then you have right here, it shows right at block one, treatment E, that each treatment consisted or was about 20 feet. And between each treatments, there is a 2.5-foot gap. Here, I have here are the photos, and then I'm gonna do um, a vocal explanation. So here we did a field design practice in class, and you could see in this photo right here, this was the 2.5-foot gap in between each treatment. Right here, we started to mark each plot. Right here, you can't really see, but we're measuring to get a precise distance to make sure that each treatment was 20 feet long. Right here, you can see from right here to right here, that is 20 feet. We have some special guests. Right here, same thing. And then the distance between is 10 feet. So 20 feet, 10. Right here, we're going to, on this slide, we're going to compare the ANOVA tables of CRD and RCBD. So the one thing that we could see that is extremely different is that the CRD does not have this extra block area. So right here, the RCBD having that extra area right here does eliminate the air. It's giving more of a statistical analysis. So that is one thing that we see different. Um, that's really the only thing that we see different, except for, of course, all these additional equations that come along with the DFSS and, of course, MS. So, which is DF is degrees of freedom, SS is sum of squares, and MS is mean square. Slide 7, I will be showing an example. I'm going to make a new one. So we will have 4 replications, so that means 4 blocks. And then we will be having 5 treatments. So we're going to type A, B, C, D, and E. What we're going to do is we're going to take that, Control C, and then now we're going to make 4 different replications of it. 1, 2, 3, 4. And once you have this, as you can tell, they're not randomized. So what we're going to do is we're going to use Excel and we're going to use their extension that you could do RAND, type in RAND, or make sure you do this, and then close the parentheses and hit enter. And right here you can see that it creates these decimals, and what you're going to do is you're going to hold the end of that box and then drag it all the way down. And then right here you can see that there's all different types of functions of this randomization. Or first, sorry, you have your decimals right here. I went a little bit ahead of myself. What we're going to do here is that we're going to highlight this. We're going to go data, and then we're going to do sort. And see now everything is randomized. So now we could do block 1, block 1, block 1. Oops. Sorry, we're gonna, don't know what that was. Block 1, block 1. And now that we have 5, and then now we do second block 2, and then so on. And then you'll keep doing all the way until 4. So that is how you randomize. Now going back to our presentation, for our last slide, for my summary, I believe the RCBD is a better way to randomize and design a research plot, especially when it comes to that slope error, because you don't want that error in your equations because then it will mess it up. So to me, I would use our CBD over CRD. Thank you, and I hope you have a wonderful day.